Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. Now see the shortcut. So now no need to construct the minimal DFA directly by seeing the number. If it is divisible by n, then how many states you will require? So see here, minimum number of states in DFA accepting the binary number with decimal equivalent divisible by n. So if you are having a binary number and if you are dividing by n, then what is going to be the decimal, what is going to be the minimum number of states in that DFA. Okay, so because minimum number of states in DFA is equal to minimal DFA accepting binary number, so that DFA is accepting binary number with decimal equivalent divisible by n. So if you are dividing by n, so n I am taking as a general, n can be anything, then what is going to be the minimum number of states? Now I am assuming if n is a power of 2, if n is a power of 2, then let n equal to 2 to the power n. So power is n. So number of states, so number of minimum states is equal to m plus 1. So if you are having, for example, I have taken that you are saying that binary number divisible by n. So now if it is divisible by how many states you will require? 2 to the power 3, we need 3 plus 1, 4 states. So you require 4 states. Similarly, when n equal to 4, so you can write power of 2, 2 to the power 2. So you require how many states? Whatever in the power 2 plus 1, that is 3. That we have seen that in minimal DFA we required 3 states. Similarly, if n is odd like 3, 5, we have seen that many number only we require 3. If it is divisible 3, 3 states. If it is divisible 5, 5 states. Number of states is equal to n. Okay, so you are going to n states. If n is odd, you are going to that many number of states. For example, n equal to 5, we need 5 states. We have seen n equal to 3, we require 3 states. Now if n is even, see this is power of 2 is also even number, but if it is not in power of 2 but it is even, then for this, okay, so keep dividing it with 2 until you get odd quotient. So you need to keep dividing the number by 2 until you get a odd quotient, and that divisible, that new number is going to be n. Okay, the result is the final odd quotient. So result is going to be the final odd quotient plus number of division done. And that many number of division you have done, that you are going to add it. So for example, I have taken n equal to 12. When you are having n equal to 12, it is a even number, but you will not able to write in power of 2. Then what you have to do? You have to divide it by 2. You got 6. So quotient is your 6. How? Till when you have to divide? Till the time you are getting, you are not getting an odd quotient. Now again 6 divided by 2, you got 3. Means n now is 3, but quotient you got 3. Now it's odd quotient. So previously you got even quotient. So odd quotient you got. So for this they are saying that you have to keep it until you got a odd quotient. You got a odd quotient, stop. So the result is final odd quotient plus number of division you have done. So final odd quotient is 3. Number of division I have done 2. So 3 plus 2, 5. So you require how many states? 5 states. So now take another example, n equal to 20. Okay, so it will be n by 2, that is 10 by 20 by 2, 10. And quotient is going to your 10. Then again n is going to n by 2. 10 by 2 is going to your 5 and quotient is going to your 5. You got a odd quotient. You got a odd quotient. So you will stop there, odd quotient plus number of division 2. You require 7 states. Like this. So now no need to construct a minimal DFA. In GATE exam they will ask the number of states in the minimal DFA. So directly by saying the n, you can say what is going to be the number of states in minimal